Hi friends, welcome to TechieMit. Good to see you after a long time. Hope you must be enjoying my previous video. So in continuation with the Java design related principle, I'm going to bring this video on solid design principles. So what are solid design principles? So let's go for it one by one. So first we'll see is the single responsibility principle. It states that the class should have only one responsibility or one principle and should have only one reason to change. So in principle terms, what does it mean? That class should have only one responsibility to handle. So let's see in our coding terms. So I have this, I created a project. In this, I have created separate packages for each of the principles. So let's start with SRP. SRP is for single responsibility principle. And I have created a class called as SRP demo. It has methods deposit money, print passbook, withdraw money. So observe that these are three different methods and there must be three different classes to handle these methods. So this should not be placed and in a single class. So to support this concept, I'll remove these methods from here. I have kept them in separate classes. So this is bank, where you were able to hold held the method deposit money and it will provide its definition. This is kiosk, and where we are able to print the passbook. It will hold its only single method, so it will follow single responsibility principle. Also we have ATM, where we are able to withdraw the money, so it will also have only one method or one responsibility to handle, that is withdrawing money. So it follows the SRP principle. So that was about single responsibility principle. Let's move to the OCP, or open close principle. So what does open close principle state? It states that the class should be open for extension and closed for modification. So in regular terms or reality, what does it mean? So consider, sorry, I have a, this is an interface that I have. This is an interface that I have called as transmission. It has one method called as mode of transmission. So it is related to transmission in cars that we have, or yeah. So we have mode of transmission as the interface, and we have transmission as the interface and mode of transmission as a method, and we have separate classes called as auto transmission, in which we implement the transmission. So it, it contains a method, it implements the transmission and it provides its own definition for the mode of transmission. So here we have manual mode of transmission, which allows the gear shift mechanism to change automatically. So auto transmission will have automatic transmission. Similarly, manual will have manual transmission. So it provides its own implementation detail for transmission interface, that is mode of transmission. Here we have manual mode of transmission, which allows the gear shift mechanism to change manually. So if you closely observe that this class is open for extension, but closed for modification, means this transmission you can implement in any number of interfaces, but you cannot provide any modifications in this interface. So this supports the open closed loop principle, which is open for extension and closed for modifications. Now let's move to the further one, that is Liskov substitution principle. So what it states: objects of a superclass should be replaceable with objects of its subclasses without breaking the application. In other words, the subclasses objects should replace the superclass objects without breaking the application. So in reality, what does it mean? So let's see. So to support that, I have Liskov substitution principle. I have created an interface called as pen. So it has only one method called as refill pens, and there is also a separate pen ink manufacturer which has its own method called the ink fill type. As we know that ball pens doesn't require any ink, so they will not. Ball pens implements So by mistakenly I've implemented this over here. It's not needed, so I'll remove it from here. And founder it. So founder pens, it required both pens and pens manufacturer. And it will implement. Yeah. So now it's implementing the infill type. So it implement both the interfaces. So this can be considered as that the ball pen is a subclass of pen, and it implements only as the method that the pen implements. The fountain pens implement both pens and pen in manufacture. So it will provide a definition to both refill pens as well as ink pens. This annulation here. So this states that all subclasses are completely substituted by its superclasses are completely substituted by its subclasses objects. This is about Liskov substitution principle. Now next we have interface segregation principle. What it states that clients should not be forced to depend on interfaces. They should not, that they do not use. So clients must only implement those interfaces that are needed. So reduce the side effects of using larger interfaces by breaking application interfaces into smaller. It's similar to the single responsibility principle that each class or interface serves as a single purpose. So instead of combining all the logic of the interface in a single interface, we should follow the principle of interface segregation. So there will be separate interfaces for separate methods or modules, which have its own specification and meaning. So in coding terms, let's see what do we mean by that interface segregation principle. So I have an interface called as mixer. As you know, the home is a home appliance mixer. They have some functionalities called as a grind, my on machine, off machine, by which we can turn the machine on, off machine will turn the machine off. There is a method for speed change in which we can increase the speed from the basic speed to the maximum speed we can increase it. And now we have Bajaj mixer. It will only implement mixer interface, so it will not implement user interface. So as it is a mixer and it's a Bajaj mixer, it will only implement mixer interface, and it will provide its implementation details for its method of the mixer interface. So you, as you can see in the code, it can only provide the definition for mixer. Similarly, we have Philips juicer. So juicer have some specific functionality as extracting juice and pulp. So it will provide definition to only that method is extracting juice and pulp. So we have segregated the interfaces such as mixer and juicer as they have separate its own mode of operation and specialty. And as per our need, it will take custom base, either it's a juicer or a mixer. We will implement the interfaces. So finally, we have dependency inversion principle. So what does it state? State that high level model should not depend on low level model, but they should depend on abstractions. So abstraction should not depend on details. Details should depend on abstractions. So in short, high level models should not depend on low level models, and they should depend on abstractions. So the abstraction must provide support to the both high level low level models. And in terms of coding, let's see what do you mean by that. Dependency inversion principle and how to implement the dependency inversion principle. So in our class S.O.L.I.D design principle, I have a package called a dependency inversion principle, in which I have an interface called as watch. Now this is an interface that let's consider it as a watch. It will show time, it will show date. Okay, these are the two methods. That's a normal functionality of any kind of watch. You can either get to know the time as well as date. And we have a class called as watch shop. Sorry, I will show some other class. That is a simple wristwatch. That is a simple wristwatch. It implements watch. So it only provides its own methods. Implements watch like show time and show date. It will provide only this simple function. And also we have a new class called as smartwatch. So it will show the time, show date, will show the today's date. Yeah, these basic functionalities are provided, as well as it will provide some additional functionality like track health. In this you will do the functions like count calories, count step, monitor the heartbeat. Such kind of functions can be performed on track health method. It will, as well as it has send mails, in which you can send and receive mails. And you have one method manage calls. You can manage calls through it. So these are some specific methods related to the smartwatch. So it provides extension to the basic watch. So now I have designed one more class for implementing this and to support a concept. So I just go to the shop and I just by using the watch I am able to create uh, I'm able to create a new smartwatch and a new simple wristwatch. So how does it support these concepts? So using watch, you can create an instance of smartwatch, and using watch, you can also create an instance of simple wristwatch. And let's see what it prints on the console. So using dependency inversion principle, using the watch, you can able to see the today's date and time. So this watch interface, it provides us the help. It provides us helpful in implementing the dependency inversion principle. So both these classes, simple wristwatch and smartwatch, they are not dependent on each other, but they are dependent on watch. So by using this watch, we can provide implementation to its classes. As you can see, it is provided by using watch. We are able to invoke the show date and show time method. So this video was all regarding solid design principles, and I made a point to keep it simple and in a short and crisp manner how they can be best explained. So do keep watching, subscribing, #TechieMit, and liking. More to come on design related principle and related videos. Bye for now.